Hi all, welcome to GAMTpedia. This is Dr. Karthik, and in this video we're going to look at part 3 of the 5-part series on GAMT learning framework. This picks up right where we left off in part 2, so if you haven't watched part 2, please have a look at that before proceeding further. Let's go. We looked at what is meant by GAMT learning framework, and in this part we're going to use that framework, apply to a topic, and we're going to learn that today. Okay, let's jump in. So what I've done is I've selected a topic from the NEET exam, which is a national entrance examination test. This NEET exam is taken by 2 million students every year in India, which gives them admission into medical school. I've selected one topic from biology to demonstrate how this GAMT learning framework works. Okay, so this is chapter 16 in the NCERT textbook, where they're looking at excretory products and their elimination. So what we're going to do is going to look at the first couple of paragraphs, and we're going to generate a GAMT for that. And then once we generated the GAMT, we're going to apply the GAMT learning framework to it. Okay, so this is the GAMT learning framework that we saw earlier. To recap very briefly, so overview in the figures, and we're going to generate a GAMT, zone of why questions, zone of comparing and contrasting, the association zone, the past exam question zone, applying the knowledge zone, and research and innovation zone. Okay, so what we're going to do first is we're going to look at the overview, which is basically going to have a quick read through the topic and understand what this topic is about, get a quick overview, and try to see if you can find some figures for this topic, and then we're going to generate a GAMT. Okay, so that's what we're going to do now. So I've read through the topics. You can see the underline some of the stuff. So animals excrete accumulate ammonia, urea, uric acid, etc. So the first paragraph deals with different types of excretory products, and then it goes to the common nitrogenous waste and discusses ammonia, urea, and uric acid. And then in the second paragraph, it focuses on what is ammonoteliism, what is uricoteliism or erythrotylic, and what are different types of animals which excrete different types of excretory products. Okay, so that's what this topic deals about. Okay, and the next thing, so main thing is urea, uric acid, and ammonia. Next we're going to look at figures. So how do we do that? So you just go to the Google, so you go to excretory products in animals, just type enter, and then just look at the images. Okay, so you get a lot of images here, and you can go through them, you can take screenshot of those images. So once you have enough images, then you go to the next step, which is where you create the GAMT. And this is the GAMT that I created based on the topic, the two paragraphs. So we have a small boat and a motorized boat. It's the bottom, and there's a motor in the back, and comes up, pumps water. This is how the water is splashing. And then you have a steering wheel of the boat. The steering wheel is slightly different design, bar in the middle. Okay, so that's the boat, that's the boat, that's the GAMT we have for this particular topic. So what does this signify? So when you look at the steering wheel here, so the outline of the steering wheel resembles the letter R. So the steering wheel is kind of this, that resembles the letter R, which stands for reptiles. The design in the middle resembles the letter B, stands for birds. One limb of the steering wheel resembles the letter I, which stands for insects. The other one is for land snails. So these are the 4 organisms that excrete uric acid. Okay, so reptiles, birds, insects, and land snails excrete uric acid. Then we come to the next part of the boat. So this part of the boat, which resembles the letter M, stands for mammals. This part of the boat resembles another M, which stands for marine fishes. And then the T here, which is the design on the boat, stands for terrestrial amphibians. So these are the 3 animal groups which excrete urea as their main excretory product. Okay, so mammals, terrestrial amphibians, and marine fishes excrete urea. And then you have the final part here, where there's again 3 groups of animals. You have this A, motor resembles the letter A, stands for amphibians. This is B, so a lot of B's joined together, and that stands for bony fishes. So all the bony fishes excrete ammonia. And then you have the lines between, which stands for insects, aquatic insects. We already saw insects here, which are land insects, and there's aquatic insects because they are in water. So all these 3 groups of organisms excrete ammonia as their common end product. Okay, hope this GAMT is clear. So once you have the GAMT, we have a place where all the information can be anchored onto. Okay, Next, how we're going to apply the GAMT learning framework. So what we've done so far, so we looked at the overview, we looked at the figures. So we looked at the overview, so we looked at the figures, we generated a GAMT. So we're going to go to the why zone, so the question zone. So why question zone? So what are you going to do? So what are the types of why questions you can ask in this topic? Now I came up with a few other questions. You might have more than this. So okay, so the question that I have is, why do we need urea and uric acid? As text says, there are three types of nitrogen excreted products. There's urea, uric acid, and ammonia. And it also says, ammonia needs a lot of water, it's very toxic. Uric acid needs very little water and it's least toxic. And urea needs some bit of water, and it can also be toxic when it accumulates. So when you have these three products, and the question that I had is, okay, ammonia is very toxic, it needs a lot of water to be excreted. But uric acid, on the other hand, is least toxic, right? And it needs very little amount of water to be excreted. So why can't all the animals excrete either uric acid or ammonia? Why do we have to have something called urea in the middle? So how are we going to answer the question? So very simple, open ChatGPT, just type in the question, why do we need ammonia, urea and uric acid? Why can't animals excrete either urea or either ammonia or uric acid only? Just type whatever comes to your mind, okay? So type in. So it just generates the answers, takes less than 10 seconds. And go through them. So toxicity, ammonia is highly toxic, excretion can be excreted into surrounding water. Ammonia is toxic, needs large volumes of water, so that's fine. Urea is less toxic, can be stored in body higher concentrations, excretion is fine. Energy cost, the conversion of ammonia to urea requires energy. So making this process more suitable for animals that have evolved to conserve water, but it can also afford energy expenditure. There you go. And what about uric acid? The production of uric acid requires more energy than urea. So there you go. That's your answer. So the reason why we need to have something called urea in between uric acid and ammonia is the farther away you go from ammonia, the more energy you need to consume. So you have ammonia, which requires less energy to produce, and when it's converted to urea, it takes a bit of energy, and when ammonia has to convert to uric acid, it consumes more energy. So the animals which excrete uric acid actually spend a lot of energy in converting ammonia to uric acid. So when you have animals who have some access to water, doesn't need to conserve that much water, can actually just convert ammonia to urea and save some energy and excrete the urea, right? So there you go, that's the answer. Okay, so the other question that I had, so kind of summarize that here. So most toxic, less energy needed. That's the kind of the key here. More energy is needed for uric acid, and that's why some animals produce urea. Okay, so what are the questions? The other question I had when I was looking at this is, why marine fishes excrete urea?